back to another video, and in today's video we're going to be learning about motion and measurement of distances. So guys, today just a tip just to keep a notebook, and don't forget to keep a notebook guys, because you need to take notes. You need to keep some notes. So guys, don't forget to keep a notebook. If you don't have a notebook, just take a piece of paper, or you can just use notes on iPad. So today's lesson plan is to learn about 5 types of motion. The questions on types of motion, or let me just question on types of motion, SI unit, reflection, and a lesson summary. So guys, now let's go into the types of motion. The first type of motion is translatory. Translatory motion is when an object moves as a whole. All the parts of the object are moving together. Example, a car. So what this basically means is when an object is moving as a whole. I'll take an example of an object which does not move as a whole. For example, guys, you can take a rocket ship. For example, you take a rocket ship. So guys, if you didn't know, rocket ships, they detach, right? Then this detaches, then this detaches. So this does not move as an entire whole. It moves part by part. So that is not translatory motion. For example, in a car, no part of the car detaches, right? The entire car moves as a whole. So that's what translatory motion is. For example, a car. But an example of not translatory is a rocket ship. In translatory, there are 2 other types of motion: rectilinear and curvilinear. So what rectilinear means is when an object follows a straight path. For example, a car, when it travels in a straight path, it follows, it's in rectilinear and translatory, because we already know a car follows translatory motion, and car, it's traveling in a straight line. So that's called rectilinear. And curvilinear, as you can see by this curve, but there's no E, but curve means like something like this, right? Something like a rainbow. So it's the same thing as rectilinear, but the shape of the path is different. For example, when a car is traveling like this, when it's taking a turn, and the turn is curved, that's when an object or a body is following curvilinear motion. More types of motion: circular and oscillatory. Circular motion is when an object moves in a curved path but keeps an equal distance from the center. Example, car in a roundabout. So guys, in curvilinear, you might be wondering then what's the difference between this and this. The difference is this is curvilinear and this is circular. In a curve, it's going like this. The distance from the middle is changing. For example, if the distance is 5 kilometers here, it's going up, so the distance is getting greater. So it's going to become 6 kilometers here. The path might something look like this. The distance is 5 here, and 6 here. So that is when an object moves in curved linear path. But in circular, it's a circle. And here it's 5 kilometers from the distance. And here it's also 5 kilometers the distance. So the radius of the circle is always the same. Now oscillatory motion. An oscillatory motion, it's when an object moves to and fro from the mean position. Example, child in a swing. It's a bit of a complicated definition, but I'll make it really simple for you guys. So oscillatory motion is when an object moves to and fro from mean position. The mean position is like this. For example, let me show you guys an example of oscillatory motion. I'll take, this is extreme, mean, extreme. When an object moves like a pendulum, like this, like this, like this, like this, like this, like this. The center is a mean position. And this is extreme position. The distance from the mean position to the extreme position is called amplitude. It's called the amplitude. So, guys, if you don't understand, I'm going to explain it because I don't have that much space on the slide. In vibratory motion, it's when an object moves from extreme position to extreme position, passing through mean position. For example, a guitar string. So let me just draw these 3 lines over here again. Okay, this is not good. So this is vibratory motion. But this is oscillatory motion. The difference between this and this is that an object in vibratory motion doesn't stop at the mean position. It just goes this, then this, then this, then this, then this, then this, then this. But in oscillatory motion, it stops at the mean position. It's like this, then this, then this, then this. It's like this, stops, then goes here. But from vibratory motion, it just keeps going, never ends. So, and in vibratory motion, when an object is at its extreme position, when it's getting pulled back down to its other extreme position, the speed is the greatest. For example, a guitar string. So guys, you might be in the guitar string, you might have noticed that guitar string actually it looks like it's going side to side, but it's actually going up, down, up, down, up, down, up, down, up, down, up, down, up, down. So that's why it's vibratory motion. Because vibratory motion goes up, down, but an oscillatory motion it goes up, down, up. Side, down, side, down, side, down, side, down, side, down. So that's the difference between vibratory and oscillatory. That means the direction. Last one, periodic motion. Periodic motion is pretty basic. Is when an object moves in equal time intervals. For example, I'll make an example over here. A car travels 20 minutes on 30 km per hour and 20 minutes with 15 km per hour. Guys, I have a question. Is this periodic motion? Yes, it is. If this comes in your test, guys, the greatest tip is to draw a diagram. Draw a diagram. It makes problem really easy to visualize, and it becomes super easy to solve. I'll draw the car path, right? So let me just divide this. In this part, it travels with 20 minutes with 30 km per hour. And in this part, it travels 20 minutes with 15 km per hour. 15 km per hour. So, it's periodic motion because the time interval is equal. If it was, let's remove this and let's say it's 15, then it will not be periodic motion because these two are not equal. Question time. A man moves on a straight road from point A to point C. She takes 20 minutes to cover a certain distance AB and 30 minutes to cover the rest of the distance BC. Man then turns back and takes 30 minutes to cover the distance CB and 20 minutes to cover the rest of the distance to a starting point. Man makes 10 rounds of the road the same way. The motion of the man is ... So when you read it, it sounds a bit complicated, guys, but it's a really simple question. Let me just rotation lock. So as I told you guys, tip, draw a diagram. We have a diagram drawn. We got to split this into 3 parts: A, B, and C. A, B. It takes 20 minutes and 30 minutes to cover BC. So, the total distance traveled, the total time taken from A to C, guys, is 50 minutes, right? He does this 10 times. 50 times 10 is equal to 500 minutes. It is periodic and rectangular. Answer. Which one is it? A, B, C, or D? The answer is C. Because it takes 500 minutes. So is periodic motion, guys, because it's in equal time intervals. It's in rectangular motion too because of this word over here. Straight road. And as we know before, rectilinear is straight. Straight. So guys, if you didn't know, get it, it's C. Rectilinear and periodic motion. Now, as we know about lesson plan, it's SI unit time. So, the SI unit for mass is kilograms. Length, it's meters. Time, it's seconds. So, the SI unit for speed is meter per second. This -1 is because meter per second is written as m over s. It's positive 1. You bring it up. You have to watch my linear equations video. To bring it up, it's going to become meter per second -1 because the plus, if you put it the other side, it's going to become minus. Time is second, so it's second. Meter is meter. And kilogram is kilogram. And for mass is kilogram. Now it's time for reflection. This is a part 1 video, guys, because this chapter is long. This chapter is long. Summary. The SI units for meter, kilogram, and second. The SI units are meter, kilogram, and second. Guys, take note that cubic meter is not an SI unit. Take note of this. This is today's note point. Motion is when a body changes position with respect to the observer. What this basically means, let me just take a blank slide. So what this means is when a body changes position with respect to the observer. Guys, look at my laser. Motion is when a body changes position with respect to the observer. What that means is, for example, a body is standing here. Then it moves here. And somebody is looking at him. And then somebody is looking at him. If the motion is with respect to him, with respect, what means is like if it is visible to him, then he is in motion. If his position is changed, he is in motion. Okay, guys, thank you for watching. I hope you enjoyed this video. I worked really hard on this PowerPoint. I'll show you guys. I think it has like 15 slides. No, not 15. Okay, guys, I hope you enjoyed this video. Thank you for watching, and bye.